ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನಾನು ಮಣಿಭೂಷಣ್ ಡಿಸೋಸ. ನಾವು ಲೈನಿಕ್ಸ್ ಎನ್ವೈರ್ಮೆಂಟ್ ಬಗ್ಗೆ ಕಲಿಯುತ್ತಿದ್ದೇವೆ. ಇಂದಿನ ಸೆಷನ್ 18 ಆಗಿರುತ್ತೆ. In today's session, we are going to look at file system abstraction, and also we will look at some of the issues that leads us to maintain the file system. To understand the topics that are covered in this particular section, you need to have a better understanding of the file system. Also, you need to know few things about the UNIX file system. If you know both of them, you will be able to understand the content. And the learning objective of today's presentation is to understand the file system and the techniques that are used to maintain the file system. Now we know that in UNIX we can have different types of file systems. In order to use different types of file system, the kernel must have an abstraction. So a kernel must be able to support more than one file system so that it can access. And we know that in UNIX there are different types of file system, like the network file system, or the other generally use the extension for file system. So somehow the kernel must be able to access all of them and to interact with all of them. In order to achieve that, it has to have an abstraction in between so that kernel can seamlessly interact with the different types of file system. Now the interface that the abstraction is provided by the inode interface. So inode acts as an abstraction between the real file system and that of the file system that is required or that is by default used by the kernel. Now there are two types of things that comes into picture. When we look at the file system, there will be two types of inodes. One is the generic inode, which is common to the UNIX file system, and there will be an inode that are specific to the one type of file system, like it could be a system 5 file system, or maybe a file system that is helping us to access the network files. So this in-core node contains the data which are independent of the file system. So for the kernel tries to access the file system independent of their types. So here we get an abstraction. So the kernel interaction with the file system is the same regardless of the file system. However, this virtualization will change their type depending upon the type of file system that we are trying to use. Okay, a generic in-core node contains the data that are independent of a particular file system. It in turn points to a specific inode that contains the file system specific data. So from the kernel points of view, kernel will interact with the generic node. The generic node in turn will point to a inode that is specific to the file system that is being used up. So this how we get an abstraction. So for a kernel, regardless of the type of file system, the interaction will be same as that of a generic inode. So this specific or a file specific inode contains the information about how to access the files or how to access the blocks within that particular file system, and maybe how to access the super block and the structure of the super block, and maybe directory structure. So we know that there are different types of file system have different ways of structure. So the specific system or a system specific inode contains that information, whereas the generic inode contains the general information like the device number, the inode number, the type of the file, the size of the file, the owner, and the reference count. Now we know that in most of the time we try to switch on the UNIX system and power it down before we switch off the computer. But there are situations wherein things may go wrong. There could be a sudden failure of power, or the system may crash while you're working with the system due to an application failure or maybe due to some hardware failure. When such a thing happens, the file system may be in the inconsistent state. Maybe half the things are being written to the disk, and if the power fails during the write operation, then some content might not have been transferred to the disk, or if the system crashes in between, the same problem can occur. In order for us to check the consistency of the system or in particular file system, we use the command FsCheck. It checks for the inconsistencies of the file system and repairs them whenever it is required. This particular command will not access the file system in the way that we generally use. What do I mean to say that? We generally try to access the content by first going to the inode, then pointing to the data block. Whereas FsCheck will directly go and access the block, or it has a raw interface that bypasses the regular inode going regular way of accessing the file, like going to the inode and then trying to access the method. So in other words, it will directly go and start reading the content from the disk. Thereby it can detect any problem that might have happened in the file system because of the system crashes or because of the power loss. Some of the problems that may encounter when the power fails with respect to the file system are as follows. A disk blocks may belong to more than one inode. So what do I mean to say is, we may have a disk block that is being used by two inode, which is not allowed. So we know that a disk block must be uniquely identified by one inode. Because of the power failure, it may so happen that the disk block might have been used by more than one inode. Also, a disk block may simultaneously belong to a inode as well as a free list. So this can also happen. So a free list says that this particular disk block is free, whereas an inode says that there is a data contained in that particular block. So this could also be a problematic. The other problem is a block number is not on the free list, nor it is contained in the file. What is the meaning of this is the block number is not part of the particular free list, nor it is a part of a file. That means it is completely lost. So we have a block that is not part of the free list. That means we can't use it, nor it belongs to any of the file. So when the power fails, when the sudden power fails, this kind of problem can occur. The third problem that we may see when the power losses or when the system fails abruptly is that an inode may have a non-zero link count, but its inode number may not exist in any of the directories. So meaning of this is, we know that whenever a file name is created, in the directory there will be an entry, and it is going to say which inode contains the information. So your file, for example, if you create a my file, so suppose if you create something called as my file, so this my file will have a inode number that says where to find the data. If there are more than one file that is accessing this particular inode, then we know that the link count in this case is 2, because two file names are accessing the same disk block or maybe the inode. Now if it is more than one, that means to say that there are two files or more than two files that are accessing it. Suppose if you delete one of the file, then the count will become 1. Suppose if you delete this name, then the count becomes 0, and when the count becomes 0, this block is released and it can be used by the others. Now suppose if the block count is more than 0, that means to say that there is let's say there are count is 3. If the reference count is 3, that means to say that 3 files are linked to this particular inode, and we must within the system we must be able to find all the names of 3 files that are currently linked to this inode. Suppose if we find that none of the directory contains any file name that is pointing to this, so you check this directory, you check other directory, you check some other directory, none of them are using this inode number. So what does that mean is this inode number should have, or in fact it should have had a 0 count so that it can be given to the free list, but the problem so that it can be reused. So but the problem is here, because it has the non-zero link count, that means somebody is trying to refer it, but when we search for the directory for the inode number, none of the directories are saying that any file is pointing to this particular inode. So this could be a problem, that something is created, so when it is trying to write to a directory, some power may fail and things may go wrong. Next one is format of the inode itself may be incorrect. So this could be a problem. So this may be because of improperly formatted file system. So when the file system is being formatted, if the power fails at that particular time, the inode structure itself may be wrong. It can happen. The next one is inode number appears in the directory entry, but inode is free. So this could be one other problem. So what is the meaning of it is the directory has some file name and a inode number. So you expect that inode to contain a reference to the data block, but you find that this particular inode is part of the free list, so it is free. So somewhere it says that this particular inode is free, and the directory says that no, this contains the reference to the data block. Again, this could happen with during the system crash, so anything can happen. The last problem that may occur is number of free blocks or free inodes recorded within the superblock may not conform to the number of existing inodes on the disk. So that means to say that this FsCheck may go and check the number of blocks. Okay, so number of let's say free block, and it may say that this is free, this is free, this is free. So it may start counting how many of them are free, and when it takes this total of how many are free, let's say here 10 are free, and it comes to the super block and verifies that the super block says that 15 inodes are free. That means the numbers are not tallying. According to the super block, 15 blocks should be free, but in reality only 5 are free, or maybe 10 are free, or according to the super block 10 blocks must be free, but in reality there are 20 blocks which are free. So there is a mismatch between the actual free block and the free block that is provided by the super block. So when this kind of problems occur, we need some software or some command to correct them so that the file system is consistent. This is one of the problem that generally happens in the file system, and fortunately Unix has a FsCheck command that you can think of using to check the file system. Now I cannot run that particular FsCheck on my system because I don't have too many file system. I am just running on a virtual machine, so it is a bit difficult. I will try to show you the way in which it works. So let me go here, okay, and let me go to the terminal, and I'm going to use the mount L command. So let me zoom in for you so that you can also see what I am typing. So I have just typed mount EL, and it's going to give me the different file system. Okay, so I'm going to check the dev SR0, which is actually a CD drive. Again, all of them are virtual. So I'm going to say FsCheck, and I'm going to say /dev/SR0. So let's try to fix, and I think it didn't get something, but there was some error, and it reported some error. Now if it was in real, if everything was proper, it would have done that thing. I will try to do it on my dev SDA1, but this is already mounted, so it is bit difficult for me to demonstrate that, but this is how you do it. So you just say FsCheck and /dev and /es/sd A1. So in fact I am referring to this particular file system, that is extension 4. Now I may get a error message because it is already mounted. So I think I got the error message saying that the file system is mounted, and it may cause severe file system damages if something really has to go down. But let me take a risk, and I press yes, but unfortunately I don't have the permission. Okay, but you can get it. It will take a slightly longer time to report to you that the file system is corrected, or it needs correction, and so on and so forth. So with that note, let me thank you for your interest. I will meet again in the next class. Thank you.